Hello viewers, you are welcome to my YouTube channel. Presenting to you this tutorial, I'm your tutor Patrick Divine, that is my name. Okay, so if you want to get in touch with me, you can contact me on this number there. That is my WhatsApp line and also my direct call line. My number is +2609753347778. So in this tutorial, we are going to revise this paper. We are still revising this paper that came at Kwame Nkrumah University for those students who are under distance. Okay, so we actually revised question 2. Okay, we revised question 2. This was question 2. Alright, so we revised these questions. So today we are going to revise question 1. We are going to revise question 1. Alright, so today we are revising question 1. So these are the questions that came. Alright, these are the questions that came. So the first question was to define a power set. Okay, a power set of A. Question 2 was to define a proper subset. B was about De Morgan's law. It was about De Morgan's law. And C was about just knowing what natural numbers, whole numbers, integers, irrational, as well as real numbers. Okay, so we can start from A there. We define what a power set is. Okay, so a power set, number 1. So this is A. Okay, so we are talking about A. Okay, we are A, number 1. Okay, so question 1, we're taught to define what a power set is. What a power set of A is. Okay, so a power set, here you are just supposed to define a power set. So how do you define a power set? So a power set is a set, okay, a power set is a set of all subsets, is a set of all possible subsets of A. Okay, should I say a power set is a set of all possible subsets of a given set. All right, so a power set is a set of all, okay, of all possible, think there's double S here, possible subsets of a given set. So a power set is a set of all possible subsets of a given set. A power set is a set of all possible subsets of a given set. Let me try to give an example here, but you are not supposed to give an example when you're given that kind of a question. You are not supposed to give an example. What you are supposed to do was just to define what a power set is. But let me try to give an example. Okay, let's say you have a set. Let's say you have set A as there are members. There is 1, 2. Okay, 1, 2. Let's say we have 1, 2 like that. So this is a set. Okay, so now when you're taught to write a power set of set A, how do you write the power set of set A? So a power set of set A, okay, so a power set of set A is denoted by PA. Okay, so if you're taught to list the members of a power set of set A, so what you're supposed to know is that you're not supposed to forget that an empty set is a set of every set. Okay, so an empty set is a set of every set. So here there was supposed to be what? An empty set. So an empty set is denoted by this one. So say an empty set is part of this. So what you're supposed to include is an empty set. Okay, so we are actually listing the power set of set A here. Okay, so set A, this is set A. Okay, so now I said that I said that an empty set is a member of every set, meaning that in here there is an empty set in here. Okay, so when you're writing a power set of this set, you need to include it. Okay, so you need to include it. So that is why I've included an empty set there. So now you need to write. So you need to write a set of 1. Okay, a set of 2. Okay, this is like this. Let me write it as a set. This is like that. 2, like that. Okay, then a set of 1, 2, like that. So now this is a power set of A. So always know that it is a power set is a set of all possible subsets of a given set. So our given set is this one. So all the possible subsets, they are these ones. These are the possible subset of what? Of set A. So this is how you are supposed to write it. But you were not taught to write an example, but I wanted you to understand what a power set is. So a power set is a subset, or is a set of all possible subset of a given set. Okay, so meaning that the power set of A, it is written as this one. I hope you understand what a power set is. I hope you understand what a power set is. So now we go to question 2. We go to question 2. Okay, so question 2, we're told to define what? To define a proper subset. To define a what? A proper subset. Okay, so before I define a proper subset, I want to give you an example so that you understand. So what you need to know what a subset is. Okay, so you need to know what a subset is before you define a proper subset. So let's say we have, this is A. Okay, so this is set A. Let's say this is set A. Set A, there is 1, 2, 3, like that. Okay, set B, there is 1, 2, 3, 1, 2, 3, like that. Okay, 1, 2, 3, like that. All right. So if you are taught to write a subset, so this is what it means. So A is a subset of what? Of B. A is a subset of what? Of B. Why is it a subset of B? Because it has all the elements that are in A, they are also in what? In B. Okay, so all the elements of A, they are also what? In B. That is a subset. Okay, so you can even write that B is a subset of what? Of A. But now, what is a proper subset? A proper subset. So I'll also give an example of a proper subset. So a proper subset, there, let's say you have the same A is equal to 1, 2, 3, like that. Then B, let's say we have 1, 2, 3, 4. Okay, so 1, 2, 3, 4. So A is a proper subset. Okay, A is a proper subset. So A is a subset, okay? So A is a subset of what? Of B, okay? So A is a subset of B, okay? But B is a proper subset of what? A proper subset of what? A proper subset of what? Of A. B is a proper subset of A. Why is it like this? Okay, so A is a subset of B, and B is a proper subset of what? Of A. Why? Because B, it has elements that are in A, and there is also another element that is there, which is not in A. Okay, so A is a proper subset of what? Of B, because it contains all the elements of A. Okay, and at least one element which is not in A. So A is a what? Is a subset of B. Okay, a subset, I should say, a subset is a set of another set. So like for instance, we have this. So let's say this is A. Okay, so let's say I'll give an example of this. So this is A. This is A right there. This is B, like that. So we have 1, 2, 3, like that. So then here we have what? We have 4. So a subset is a set of another set. A subset is a set inside another set. Okay, so A is inside what? Is inside set B. So set B is a proper subset. A proper subset is a set that has at least one element which is not in what? In A. That is what a proper subset is. So it has at least one element that is not in A. So that is what a proper subset is. So that is what you're supposed to write. A proper subset is a set that contains at least one element that is not in another set. But that set has the elements of it, they are in what? They are in B. Okay, so that is what we call a proper subset. So you are supposed to give definitions, but I also gave you explanations. All right, so we go to the second question. We go to the second question, and the second question talks about De Morgan's law. Talks about De Morgan's laws. De Morgan's law. Okay, so here, if you look at this question, there, so it's saying that let A and B be two sets. Okay, so let A and B be two sets. So they're saying that show that A intersection B complement, okay, is equal to A complement union B complement. So now how do we show that? Okay, so let me write them down here. Create more space. Let me create more space. Okay. So this is what we call De Morgan's law. Okay. So this one, it came from De Morgan's law. So De Morgan's. Okay, De Morgan's. I don't want to just solve this question, but I want to solve all those expressions that are on De Morgan's law, so that you are able to understand everything. Okay, De Morgan's law. I'm trying to solve everything because it's not only this question that you're going to be given. Okay, in case the other question comes on De Morgan's law, so you need to know both of these expressions. So number 1, let's say we have that same one which we were given. So the one that we were given, it's actually this one. Let me just write it down. So it's A, it is A intersection B, okay, then complement is equal to A complement union B complement, like that. Okay, so then I'll do this. I'll just cut here, then I'll write the other one. Since De Morgan's law has 2 expressions, okay, so De Morgan's law has 2 expressions, so there is also this one, which is A union B, okay, complement is equal to A complement intersection B complement. Okay, so we are going to start with the one that you were given, or with the one that came in this paper, like that, this one. So we are going to start with that one. So the way we solve De Morgan's law, I want you to pay attention on this one, the way we solve De Morgan's law. So we say that let X be a member, okay, let X be a member of what? Of this first part which is here, okay. So we want to show that this part on the left hand side is equal to this part on the right hand side, okay. So now we say let X be this which is on the left hand side. So let X be a member of this, okay, be a member of what? Of A intersection B complement. That is what we firstly do, okay, that is what we firstly do. From there now we say, okay, this complement, you explain what this complement means, okay, you explain what this complement means. So it means that when it is A intersection B complement, it means that X is not a member of what? Of A intersection what? Intersection B, okay, it is not a member of what? Of A intersection B without the complement, okay, that is what it means. So I said let X be a member of A intersection B complement. So this means that X is not, okay, I've put this to show that it is not a member of what? Of A intersection B, okay. So this is what it means. So you explain further here, okay, you explain further here. So you say X, this statement, it means that X is neither a member of what? Of A, or a member of what? Of what? Of B, like that. This is what it means, okay. So X is neither a member of A or a member of what? Of B. That is what it means. So if it is not a member of A, okay, if it is not, so this statement now, this statement again, it means that if it is not a member of A or a member of B, meaning that X is a member of what? Meaning that X is a member of A complement, okay. So since it is not a member of A, okay, since it is not a member of A, meaning that it is in either in A complement or is a member of what? Of B complement. That is what that statement means. I hope you are getting the point. I am slow. I want you to understand. Okay? So, this statement here, it's saying that X is not a member of A, or B is not a member of what, or X is not a member of what, of B, like that. Okay, so this means that if it is not a member of A, meaning that this X, it is in what, in A complement or in B complement. So it is either in A complement or in B complement. Now what does this mean? What does this mean? What does this mean? So what you need to know is that this O, it means union. Okay, it means union. It means union, meaning that X is a member of what? Of A complement union B complement. That is what it means. Okay, that is what it means. So from here, at first we started with this one. Okay, at first we started with this one, and we've ended with that one. Okay, so this is the last one. So if you look at this one, is this one. So meaning that we have shown that this part is equal to that part. So you say since A intersection B, okay, complement, okay, is a subset of what? Of A complement union B complement, then we say therefore A intersection B complement is equal to A complement union B complement, like that. Hence shown. You've shown. I'm sure you are able to understand. So this is what you are supposed to write. Okay, so that is what you are supposed to write for you to get those marks that came, which were 5 marks. Okay, 5 marks. All right, so now I hope you've understood this question. So this is the part that comes on De Morgan's law. All right, and there is also another part that comes, which I've written here. So in case you're not given to prove this, you'll be given to prove this. So there are only 2 expressions of De Morgan's law. So let's prove this one as well, in case you are given this kind of a question on De Morgan's law. So now you need to prove that this part on the left hand side is equal to that part on the right hand side. Okay, so now here we go. Let's go. So we do the same thing. We say let X be a member of what? Of this first part. Okay, let X be a member of this. So let X be a member of A union B complement, like that. Okay, so now from here you just explain this statement, what it means. So it's about explaining statements. That is what De Morgan's law is. So you say this, it means that X is not, okay, a member of what? Of A union B. It is not a member of A union B. This is what it means. Complement, this complement, it means not a member of. That is what complement means. It means not a member of. Okay, it means not a member of. So this complement means not a member of. So I've just interpreted this expression right here. So I've said X is this part. So you let X to be a member of that, and now you explain this statement. So this statement, it means that X is not a member of A union B, like that. There is no complement here. So if it were a member, we would have put what? Complement there to show that it is a member. But it is not a member. So now, this means that, so this statement, so we said that it means that this which is here, it means what? Okay, so that what is here, it means what? It means O. Okay, so we say X is not a member of A, or X is not a member of what? Of B. Okay, I hope you are getting the concept. So this, it means what? It means O. Okay, so this, it means what? It means O. This union, it means what? O. So X, so this statement means that X is neither a member of A, nor a member of what? Of B, like that. Okay, I hope you are getting that concept. I hope you are getting that concept there. Okay, I hope you are getting that concept. Okay, so meaning that this statement, it also means that X is not a member of what? Of A and what? And B, like that. It is not a member of A, meaning that it is not in A and it is not what? In B. Okay, it is not in A and it is not what? It is not in B. This is what it means. It is not in A. Okay, X is not in A and it is also not in what? In B, like that. Okay, so if it is not in A and in B, meaning that X is in what? It is in what? In A complement, and in what? X is in what? In B complement, since it is not in what? It is not in A and it is not in B, meaning that it is in what? In A complement, and X is in what? In B complement, like that. Okay, so what you need to know is that and, it means what? It means intersection. And means intersection. So meaning that this statement is just saying that X is a member of what? Of A intersection what? Intersection B, like that. As simple as that. So this is it. So if you look at this part here, this is A intersection B. Oh, should we, here we are supposed to put complement like that. So this A intersection, A complement intersection B complement, so you will be able to see it here. Okay, you'll be able to see it there. So meaning that this part is equal to that part. So you say since, okay, since A complement, A, you get the first part, this part here. Since, okay, since A intersection B complement is a subset of what? Of A complement intersection B complement, you get this last part. Therefore, A intersection B complement is equal to what? A complement intersection B complement. So you end there. That is all. That is all. So for this one as well, you'll be given 5 marks like that. So that is how it goes. So we have proved De Morgan's law. I'm sure you are able to understand what De Morgan's law is. Okay, they'll ask you to state what De Morgan's law is. So if you ask the questions that state De Morgan's law, so this is what you're supposed to do. So when you are asked to state De Morgan's law, so there are questions I want to tell you. So there are questions where they'll ask you that state De Morgan's law. They'll just ask you to what? to state De Morgan's law, and the question will be what? Will be 2 marks, okay? Will be 2 marks or 3 marks. So what you need to do is just to remember these two, okay? You need to know these two. You need to know those two, because I've come across a question which says that you should state what De Morgan's law is. Okay, so what you're supposed to write there, you're supposed to write De Morgan's law states that A intersection B complement is equal to A complement union B complement, and you write this again. So you should know these two in case you come across such a question. So De Morgan's law states that this, you write this. Okay, De Morgan's law states that you write that, and you put and this part. That's all. You'll be given 2 marks from there. Okay, I'm telling you all this because I've seen such kind of questions. So that is how you answer that. So from here we have gotten our 9 marks. So now this part now. This part is the simplest part here. Okay? So here you are asked what? You are asked just to mark. Okay? Just to mark. In the table below. So this question came as, let me just try to zoom it. Try to zoom it like this. Oh, let me try to do it this way. I'm sure you're able to see. So it says that in the table below, describe each of the each of the numbers as A, number 1, okay, natural numbers. Number 2, whole numbers. Number 3, integers, rational numbers, irrational numbers, and real numbers. So what you are supposed to do is just to know the definitions of these. If you know the definitions of these, you will know what they are actually asking you here. Okay? So you need to know what they are asking you right here. So what you need to know what natural numbers are. So now, what are natural numbers? What are natural numbers? So let me try to give you an example of natural numbers. So natural numbers, they are just counting numbers. So you can actually define them as counting numbers, starting from 1, 2, 3, 4, 5, 6, 7, going up like that. So that is what natural numbers are. So you are supposed to mark what natural numbers are. So like here, the way they marked, so these they are not natural numbers, that's why there is X there. Okay, so you are supposed to mark mark natural numbers here. So natural numbers are counting numbers from 1 going up. Okay, so natural numbers are counting numbers from 1 going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just like that. So here, if you can see here, this one is a natural number here. Okay, so this one is a natural number here. So you are supposed to just to mark it like that. So it is only a natural number which I'm seeing here. Okay, so meaning that all these they are what? They are not natural numbers. They are not natural numbers. So that is what you are supposed to do there. Okay, that is what you're supposed to do there. So you're supposed to mark what? A natural number here. Even here, you need to mark what a whole number is. So whole numbers, you need to know what whole numbers are. Whole numbers, they are counting numbers as well. They are counting numbers, but they include what? They include 0. Okay, so they are counting numbers, but they include 0. So they are not. So whole numbers are numbers. Whole numbers are counting numbers, including 0. So they start from 0, 1, 2, 3, 4, 5, 6, 7, 8, going up like that. So whole numbers, they are numbers. Okay, they are numbers. They are counting numbers, including 0. They are counting numbers including 0. What I mean, most of you probably might be confused. Let me just, I think I should be giving even examples from here, just from here. Okay, I'll be giving examples just from here. So let me say, so we are natural numbers. Okay, natural. So these are 1, 2, 3, going like that. Okay, so whole numbers now. Whole numbers. So they are counting numbers. Okay, they are counting numbers including 0, meaning that they start from 0, 1, 2, 3, okay, 4, 5, 6, 7, 8, like that. I'm seeing 8 going there, like that. I've put 8 because I've seen 8. So whole numbers, they are counting numbers, but they include what? 0. So the difference is that, the difference between natural and whole numbers is that these, they include 0, like that. So I have seen 8 here. Okay, so 8 meaning that it is a whole number. 8 is a whole number because it's there. So I was just supposed to mark it like that. Then this is negative. Okay, this is negative 7, meaning that it is not. This is not. Okay, this is not. That is not. That is not, like that. So that is what you are supposed to do. What are integers? What are integers? So integers, they are negative and positive numbers, including 0. Okay, so that is what integers are. They are negative and positive numbers, and they include what? 0. They are negative and positive numbers, but they include what? They include 0. So they are negative. So negative 1, negative, let's say your numbers that are starting from negative 5, negative 4, negative 3, negative 1, 0, 1, 2, 3, 4, going like that. Okay, so integers, they are negative and positive numbers, but they include what? They include 0. That is what you're supposed to know. Okay, that is what integers, that is what we call integers. So you're supposed to know the definition. So these are negative, these are positive, but they include what? They include 0. So let's check here. What do we have? Do we have integers here? Do we have integers here? So if we see here, we have negative 7 as an integer. So we say, we mark, okay, we mark like that. Okay, we mark like that. Is this an integer? No, it is not an integer. So this one is an integer. Okay, it is an integer because it is a positive number. It is going like that. It is a positive number. So like that. Okay, so you're supposed to mark like that, like that, like that, like that. Okay, so that is what you are supposed to do. What are rational numbers? Rational numbers. So rational numbers, they are numbers that are presented in a form of P over what? Over Q, like that. P over Q, let me write P over Q, like that. Then Q, this one which is down here, Q, which is down here, it is not supposed to be equal to what? It's not supposed to be equal to what? To 0. What I mean, there are numbers that are 1 over 2, 2 over 3, like that, 4 over 5, like that, but not these ones, where we have 2 over 0, like that. No. Okay, not like this. So these are rational numbers. These are what? They are rational numbers. Rational numbers. So rational numbers are like this. Okay? They are written in the form like this. Ratio. Rational comes from what? A ratio. So a ratio, those ones which you used to write them like 3, comma, or 3 to what? To 2. This means that it is 3 divided by what? By 2. That is what it means. So this is also 3 divided by 2. That is what it means there. So rational numbers, they are numbers that are written in form of this, okay? Where the one which is down here, it is not equal to 0. It is not equal to 0. Okay? They are not equal to what? To 0 like that. So now there is another definition of what? Of rational numbers. There is another definition that you need to know about rational numbers. So these are also numbers like this, okay? There are numbers like this. There are numbers like this. So when you divide these numbers, they have so there are numbers whose decimals comes to an end. Whose decimals comes to an end. What do I mean by that? Decimals comes to an end. So when you want to find the decimal of this number, that is 2 into that is 0, okay? That is 0, okay? Point, you put a point, then you put 0 there. Then 2 into that, it is what? It is 5. So the answer what has ended like that, okay? Have ended like that. So there are numbers that have decimals that come to what? To an end. They end like this. And also there are numbers which they have decimals that have repeating decimals. It has repeating decimals like 3, 3, 3, 3 like that. Then they end like that. Okay? So rational numbers are they also have what? Ending decimals like that, and also they have what? Repeating decimals. That is what rational numbers are. I'm sure you've understood there. So I'll explain more when it comes to irrational numbers. So let's mark what rational numbers are here. Let's mark what rational numbers are here. So I said that there are numbers that are presented in form of this, okay? In form of that, and they have ending decimals like this and like that. Okay, so let's check here. So this is a rational number. Okay, this is a rational number, but this one is not. It is not a rational number. So -7, it is not. Okay, so this 14/5, it is a rational number. You mark like that. This is 8, is not. Okay, 8 is not, like that. Okay, then 5 is not. Root of 5 is not. This is a rational number. Okay, it is a rational number because it has a decimal that is ending there, 5.9 like that. So this one is a rational number. Then this one is not, like that. Okay. So what about irrational numbers? What about irrational numbers? What are irrational numbers? Okay, so irrational numbers, these are numbers whose decimals do not come to an end. Whose decimals do not come to what? To an end. That is what irrational numbers are. So you find these like, let's say root of 2. When you divide root of 2, okay, when you get a calculator and you do root of 2, you find an answer which is like this: 1.7232058 like that. They don't end. They will be just going, okay, and they are actually different here. Okay, they are different, but for rational numbers they are like this. Okay, they have the same, they end, but these ones, they are like this. Okay, so these are the irrational numbers. There are numbers there that are under a square root. Okay, they are under a square root, and they have decimals which do not have what, an end, and they do not have a repeating pattern. They do not have a repeating pattern. They are not repeating, like 3 3 3 3 2 2 2 2, like that, 5 5 5 5, like this. So they are just different. There is 1, there is 7, there is 3, there is that. So mean that these are irrational numbers. Okay, they are under what? Under a square root, like that. Okay, so let's check here if we have that. Suppose we have that here. Do we have? Yes, we do. So there is this one. It was even marked like that. It is a root of 2. This one, no. Okay, it is not under a square root. That one, no. This 8, no. This 5, it is under a square root. Okay, so that is what? Irrational. Then 5.5, or this one, it is not like that because it has an ending. Okay, it is ending like this, but irrational, they don't end, they just like that. So this one, yes, it is under a square root like that, so it is irrational. Now, what are real numbers? Okay, what are real numbers? So real numbers are a combination of all these: natural, whole numbers, integers, rational, irrational. Okay, they are a combination of, so like it is like real numbers, it is just a mother of all these. Okay, it is just a mother of all these, is a mother of all these irrational, of all these numbers which are here. Okay, so meaning that all these numbers, natural numbers, whole numbers, integers, rational and irrational, they are in real numbers. Okay, so that is what it is. So it is a set of all the numbers that you can think about, that is what we call real numbers. So meaning that a real number, it can be what? A natural, it can be a whole number, it can be an irrational, it can be what? It can be a rational like that, it can be an integer like that. So you are supposed to mark everything like that. So that is what you are supposed to do right there. That is what you are supposed to do right there. Okay, so in that previous video, I didn't solve this question because of time. Okay, I didn't solve this question because of time, but let's solve it together. I'm sure you've understood how to answer those questions. Let me just try and solve those questions, just to make everyone understand. So if you are new to this YouTube channel, don't forget to subscribe. Even if you are under my teaching or you are not, make sure that you subscribe to the channel for more videos, for more lessons. So we have this question here, this one that came. So if alpha and beta are the roots of this equation, okay, show that this is equal to that. Show that alpha cube plus beta cube is equal to that. So we have this equation. Okay, so we have x to the power 2 minus 3x plus 4 equal to 0 like that. Okay, equal to 0 like that. So I didn't solve question in that last video, that previous video. So we are solving this. Okay, so we have this equation and we also have this down here. So they're asking us to show that alpha cube plus beta cube is equal to 9. So alpha cube plus beta cube is equal to what? Is equal to negative 9. Okay? Is equal to negative 9. So we are solving that question. Okay? That is the question that we are solving here. So now the first thing that you're supposed to do, okay, we are solving this question. So the first thing that you're supposed to do is to find the sum. Okay? This is the sum and the what? The product. That is the product. So you need to know the formulas of this. I taught you in the last in the previous videos. So the sum of this one, the formula is negative b over what? Over what? Over a. Then this one is what? Is c over what? Over a, like that. So we derived these. You should know them. Okay? So from this equation that we are given, this one, so we know that this is a, this is a, this is b, this is c, like that. So the coefficient of this one is, this is a, this is b, this is c. So mean that a is 1, b is negative 3, okay, c is what? Is 4, like that. So we write, we say equals to, what is b? B is negative b. So b, we say negative, so this is negative. Negative what? Negative 3. So negative 3, like that. Okay? So b, so this is negative. So we put negative 3 like that. Over what? A. A is what? A is 1, like that. So a is what? Is 1. Okay? Then we solve this one. So this is negative times negative, that is positive, like that. So meaning that even when 1 goes in there, meaning that it's going to be what? Positive 3, like that. Okay? So now what is c? What is this? What is this? So alpha, beta, like that. So let's solve this. So what is c? C, we have 4. C is 4 there. So we put 4. What is a? A is 1. Okay? So mean that 1 into 4, it is what? It is just 4. Like that. So this is the product and the sum. So we have found this and that. Alright? So now, the other thing that we're supposed to do now is to derive the formula for this one. So if you know the formula for this one, there's no need to start deriving it. You can write it down. But I will show you how to derive this formula. So you need to know how to derive this formula. Alpha to the power 3 plus beta to the power 3. What is this? What is this? Okay, so if you want to derive this formula, what you can do is actually doing it like this. So you say this, it can also be written as alpha plus beta, like that. Then to the power what? To the power 3, like that. That is how it can be written. Okay, that is how it can be written. So if you want to expand this, you can expand it as alpha plus beta, then alpha plus beta. Okay, like that. Like that. So there are 3 things. Okay, this, it means that it is like this when you are trying to expand. So let's try to expand this. If we can expand, so we can start from here. Okay, we expand this. Okay, so we can expand from here. So here we don't even forget this, so meaning that you need to write it. Okay, beta, like that, to the power 3. So when expanding these two, you say alpha times alpha. So you multiply this by everything which is in there. So you say alpha times alpha, it is alpha squared. Then alpha times beta, it is what? Alpha beta, like that. Then this beta times alpha, it is what? It is going to give you alpha beta again. Then beta times beta, it is going to give you what? Beta squared, like that. Okay, so don't forget this. We haven't done. We are not done with this, so we bring it down right there. So alpha plus beta like that. Okay, alpha plus beta like that. So we can even add the like terms here. Okay, we can even add the like terms here. So we say alpha plus beta is equal to what? To 2 alpha beta. But let's just do this to create more space. We write this. So we write plus 2 alpha beta. Okay, I was supposed to write it here, but I just want to write it there. But for you, just write it there. Okay, I'm just trying to create more space and to save time. So you go on, you write alpha plus beta to the power 3 is equal to, then you need to multiply this again with this here. You need to multiply these variables here with that. So the meaning that this will be multiplied by everything, this will be multiplied by everything like that. So mean that alpha times alpha squared times alpha, it is going to be what? It is going to be alpha to the power 3 like that. Then this same alpha times alpha squared times beta, it is going to be alpha, this one is squared, you are multiplying with this, so mean that it's going to be alpha what? Alpha beta like that. Okay, so I've multiplied this one times that one, so we are done. Let's go to this one. So we are multiplying alpha 2 alpha beta times alpha. So this is 2 times that, so mean that we are going to have, automatically we are going to have 2 there. Okay, so we are going to have 2, then alpha beta times this. So this is just where you multiply this times that is alpha squared, then there is also beta, you write there. I'm sure you understand there. Okay, like that. I'm sure you're able to see it there. Okay, this same thing you multiplied with that one, so it is going to give you what? This automatically there will be what? There will be 2 there. So then alpha beta times there. So the one that is going to be squared is what? Is beta. Because this is beta times beta, mean that it's beta times beta. The alpha will be just like that. So mean that it's going to be alpha beta squared like that. Okay, so then we multiply these times everything again. So beta times alpha like that, it is going to be what? Beta squared times alpha, it is going to be alpha beta squared. Okay, alpha beta squared, then beta squared times beta, it is going to be what? It is going to be beta to the power 3 like that. Beta to the power 3. Okay, so what you are trying to come up with, it is this original thing. Okay, so that is what you are trying to come up with as you are doing this. You are trying to find the formula for this one. So wherever you are going to see these two, you're going to see alpha squared and beta squared. Just collect them as the like terms. Okay, in here. So here we are able to see alpha to the power 3. Even let's check, do we have alpha beta to the power 3, beta to the power 3, beta to the power 3? So beta to the power 3, it is right here. Okay, so we are going to get this one and that one. Okay, so don't forget, you need to be copying this as you go. So alpha plus beta to the power 3 is equal to this alpha to the power 3 plus beta to the power to the power 3. That is what we've gotten. We have gotten this first one and the last one there. Okay, so now here we can add the like terms. We can add the like terms. Do we have the like terms here? So here we have alpha squared. Okay, alpha squared and beta. So alpha here it is squared, but beta is not what? Is not squared. So do we have alpha squared here? Yes, we have alpha squared, beta is not squared. Alpha squared, beta is not squared. Okay, so how about here? Here alpha is not squared, but beta is squared. So mean that these are like terms here. So there is alpha squared beta. then 2 alpha squared beta, mean that it is what? It is going to be what? It is going to be 3 alpha squared beta, like that. Have you seen? Okay, so this one is just like, it is just 1. There is 1 here. That is what it means. So just add 1 plus 2, that is 3, then you just copy this. Okay, same applies here. We have 2 alpha. Okay, so we have alpha is not squared. Even here, alpha is not squared. Beta is squared, beta is squared. Meaning that it is also what? It is also 3 alpha beta squared. Okay, so you need to know that these are not the like terms. They are not like terms here. These ones, they are not like terms. Okay, they just have something in common. They just have something in common. Okay, so you copy this. Alpha plus beta to the power 3 is equal to alpha squared to the power 3 plus beta to the power 3. Now, right here, okay, if you look at these ones, they just have something in common. What is that is in common? What is that? So you need to factorize this. Okay, you need to factorize this. So what is common here? We have 3. There is 3 here. There is also 3 here. There is alpha. There is also what? There is also alpha here. There is beta. There is also what? There is also beta here. So mean that we are going to write alpha what? 3 alpha beta is common. Okay, 3 alpha beta is common. So 3 cancels that 3. Then this alpha cancels this power. Okay, so this alpha cancels that power, mean that we are going to have what? Alpha there. Okay, this beta cancels that beta. Okay, so mean that we are done with this one. Plus, how about this one? So this 3 cancels that 3. This alpha cancels that alpha. Okay, beta cancels that power there. So mean that we're going to have what? We are going to have beta. I hope you are getting the concept here. So from here, you know that you need to make this as the subject of the formula, because this is what we are looking for. This is what we are looking for right here. Okay, we are looking for that one. So we have this expression here. How do we make this one the subject? We are moving this part to the other side. That is what we're supposed to do. So we are moving this to the other side so that this should remain as the subject. So meaning that we are going to have alpha plus beta to the power 3. When this part comes this side, this is positive. When it comes this side, it becomes negative. 3 alpha beta, okay, open bracket, alpha plus beta, like that. Okay, so is equal to what? Alpha to the power 3 plus beta to the power what? To the power 3. So meaning that we have found what? The formula. Okay, we have found now, we have found what this is. So this is this. Okay, so when there is an equal sign, when there is 1 here, meaning that also here must be what? Must be 1. Okay, also here must be 1. When you have x here and they're telling you that there is 1 this side, mean that what is x? X is 1. Okay, so when we have this part here, okay, so when we have this part, they are telling us that this part is also this what? This part equal. That is what it means. When there is 0, mean that also here there must be what? There must be 0. So we have now found out what this is. So this is the formula for this. This is the formula for this expression there. So now what we have in the question is this part. We have this. We have to answer this. Okay, we have to answer that. So we now know what this is. So what we are going to do is just to replace what this is. Then we start solving. Okay, then we start solving. That is what we are supposed to do. So let me just try to create more space from right here. Just try to create more space. I'm sure you are understanding. Don't forget to subscribe to the channel. If you haven't subscribed yet, don't forget to subscribe to the channel, because there are going to be more things that I'm going to be posting on this channel, and you don't need to miss out. So make sure that you subscribe. So you know that this one, we have found it, and it is what? It is this thing right here. So it is alpha plus beta to the power 3, and it is in the bracket, then minus 3 alpha beta plus alpha beta. Okay, so let's replace this part. Let's replace. So it is alpha plus beta like that to the power 3 minus 3 alpha beta. Okay, alpha beta open bracket, then there's alpha plus beta like that. So we have just replaced this one. So it is saying that it is equal to what? Negative 9. It is equal to what? To negative 9. Let's find out if it's equal to negative 9. If this equation is going to be negative 9. Let's see if this will be what? Will be negative 9 as well. This is what it means. I said that if there is negative 9 this side, also here there must be what? Negative 9. So now let's find out if this expression is equal to what? To negative 9. Okay, so right here, don't forget we had found this. Okay, we had found that alpha plus beta is 3. Okay, alpha plus beta, we have found that it is 3. And what? Alpha beta, we had found that it is what? It is 4. Okay, so now we had found that alpha plus beta is 3. So let's try to put alpha plus beta there. So alpha plus beta, we have said that it is what? It is 3. So let's try to put 3 here. Okay, so it means that it is like this. Then minus 3 open bracket. What is this? What is this? So this is alpha beta. Alpha beta, we have said that it is what? It is 4. So let's put 4 here. Let's put 4. Then multiplied by, this is alpha beta. Alpha beta, it is what? It is 3. We have said that it is 3. So it is equal to negative 9. So let's see. Let's find out it's equal to negative 9. So alpha, so this is 3 to the power 3. 3 to the power 3 just means that 3 multiplied by 3 multiplied by 3. That is what it means. So 3 times 3, it is what? It is 9. Then 9 times 3, it is 27. So meaning that here we have what? We have 27 here. Then this is negative 3 over, negative 3 multiplied by 4. So what is negative 3 multiplied by 4? Negative 3 multiplied by 4. So what is 3 multiplied by 4? 3 multiplied by 4, you find that it's what? It is 12. 3 multiplied by 4, it is 12. And that 12 again, you're supposed to multiply it with what? With this. So 3 multiplied by 12, it's going to be what? Negative what? Negative 12 multiplied by 3. Okay, so just bring it down like that. Don't forget that here there is negative 9. So negative 12 multiplied by 3. So negative 12 multiplied by 3. So this is 12 multiplied by 3. Okay, so 3 times 2, that is what? That is 6. 3 times 1, that is 3. So this is 36. So mean that this is negative 36. Okay, so that is negative 36 equal to what? Negative 39. So now let's find out if this, let's find out what this is. So this is negative 39. Okay, so know this rule. Okay, know this rule. When you are subtracting a bigger number from a smaller number, this is what you are supposed to do. Okay, in case you forgot from secondary, but they didn't teach this, but I'm going to teach you this. Okay, so when you're subtracting a bigger number from a smaller number, what you do is get that bigger number, put it on the right side. So get that bigger number, put it on the right side, on the left side. Okay, on the left side. So put it on the left side, which is 39, like that. Okay, put it on the left hand side. Then that smaller number, put it on the what? On the right hand side, which is 27, like that. Okay, so you know that this is positive. This is a positive number. This is a negative number. So what you do now, multiply this sign, multiply the sign. So negative times positive, or positive times negative, it is what? It is negative. So put that sign there. It is negative. Then subtract now. So that is 39 minus 27. So 39 minus 27, this is just 39 minus 27, like that. So 9 minus 7, you find that the answer is what? 9 minus 7. What is 9 minus 7? Oh no, here I made a mistake. Here I made a mistake. This is not 39. It is 36. We had found that it is 36, but I've put it 39. I'm sorry on that one. So here it's 30 what? It is 36. Like that. So meaning that here also it must be 30 what? 36. 30 what? 36. So here this is what we do. So 6 minus 7, it can't. So we borrow 1 from 3. This will become 2. That is 16. What is 16 minus 7? 16 minus 7, you find that is what? It is 9, like that. Okay? So then 2 minus 2, it is just 0. So mean that the answer is what? Is 9 here. So mean that the answer is what? Is 9. But when you reach here now, get the sign of a bigger number. Okay, so the sign from the original question, the sign of a bigger number is what? Is negative. So it is negative. That is how you solve this. Okay, so meaning that here we have negative 9. Here we also have what? Negative 9. So that means that we have shown. So you write hence shown, like that. Okay, so that is what you are supposed to do. Only this, then you get your 5 marks. As simple as that. So let's solve the other question. Okay, oh no. So the other question was even concerned with that same question, which is x to the power 2 minus 3, the same one, minus 3x, okay, then plus 4 is equal to 0. This is it. So now the question is that we should find the value of what? The value of 2 alpha over beta squared plus 2 beta over alpha squared, like that. Okay, so we need to find the value of this. So we know that alpha beta, we had found that alpha plus beta is equal to what? Is equal to 3. And alpha beta is equal to what? To 4. That is what we had found. So we need to find, we need to express this in terms of these two. So here, if you look at this one, this is just a fraction. Okay, this is just a fraction, and you need to find the common denominator. The common denominator is what? Is alpha, is what? Is beta to the power 2. Okay, alpha to the power what? To the power 2, like that. These are common denominators that we have. So we say beta into beta, this one, beta cancels that beta, then what remains is this one. So this one multiplied by that, so that is going to be 2. This is alpha beta, this is alpha squared. So when it is multiplied with that alpha, it is going to be what? To be what? It is going to be alpha to the power 3, like that, plus this alpha squared cancels that, then this same, when then beta we multiplied by everything, meaning that it is going to be what? 2 beta squared, like that. Okay, 2 beta squared, like that. So from here now, from here, we know that there is something common here. There is something common, meaning that we are supposed to factorize here. So what is common? We have 2. 2 is common there. So if we have 2 there, we have 2 is common. So what is going to be there? So 2 in there. So it is going to be alpha to the power 3 plus what? Plus beta to the power 2 to the power 3, sorry, beta to the power 3, even here to the power 3 like that. Then there is over. So when you multiply alpha times beta, when you multiply alpha times beta, it is going to be what? Alpha squared, then beta squared like that. Okay, so you know the formula for this one. The formula for this one, we derived it. Okay, so we need to replace this one by that formula that we are just from deriving. So we are going to say it is what? 2. This 2 is just outside. Okay, then what is inside? So inside we have alpha, that formula that we are just from deriving, alpha plus beta. Okay, then it is what? It is to the power 3 minus, there is minus, okay, there is minus 3 alpha beta, open bracket, there is what? Alpha plus beta. This is the formula that we are just from deriving. Okay, so there's just a 2 here, don't be confused, there's just a 2 here. So you just put it like that, okay, to show that this 2 is multiplying with everything, to show that this 2 is multiplying by everything. That is why I've put this bracket outside here. Okay, over like that. This one, okay, this one you can factorize it, this one. Okay, or should I say this one can also be written as what? It can also be written as alpha beta, okay, to the power 2. Okay, alpha beta to the power 2, meaning that this, it is a square of this one and that is a square of that one. So from there now it's just that replacing the values of this. So you say 2, okay, open bracket like that. What is alpha plus beta? Alpha plus beta, we had found that it is what? It is 3. Okay, alpha plus beta, it is 3. Then alpha beta, it is what? It is 4. So here alpha beta, it is what? It is 3. So you say 3 to the power 3, then minus 3, this part here, it is what? It is 4. Then here this part, we know that it is just 3 like that, over, so like that, then over. So you know that this alpha beta, it is 4. So it is just saying that it is to the power 4 like that. Then from here you just solve, as simple as that, just to get your 5 marks. Just imagine 5 marks just to do this. So that is, this is 27. Okay, 3 to the power 3, it is 27. 27, this is 3 times 4, it is what? 3 times 4, it is 12. Then 12 times 3, it is 36. So that is negative 30. 36 like that. Okay, then there is over. This is 4 times 4, that is 16. So you put over what? 16. So you know that this part here is negative what? This is 27 minus 36. It is negative 9. So we go here, we just put 2 outside. Then there's negative 9. Then there's what? There's 16 here. Okay, there's 16 there. Then you say 2 times that, it is what? Or you can even divide this 2 into that. 2 into 2 here, it's 1. Then 2 into 16 is what? It is 8 like that. Then you write 9 over 8 like that. Or you can multiply this 1 times that one, just the same way. So mean that it's going to be negative 9 over what? Negative 9 over 8. So this is the answer. This is the answer. Then you are done with that paper. You've gotten your 100 marks on that one. Okay, so I thank you for your attention. Okay, so if you're new, don't forget to subscribe to this YouTube channel. Don't forget to subscribe. Thank you for your attention. Continue having a productive evening.